All right, here's notes on 12.4, volume of prisms and cylinders. So earlier this chapter, we looked at a lot of surface areas, and now we're switching to volumes, which is the amount of cubic inches contained, or units contained inside a solid's interior. Volume is often related to how much something will hold, so often with liquids of some type like that, or the volume of a box, so how much space is inside that you can fit things in. So volume is a measurement that we use a lot. If you have to get things like cement poured, you have to get the volume by the cubic yards or cubic centimeters, so on. So you'll notice I put there with the volume that your labels are in cubic. All right, so a lot of formulas. You want your green formula sheet out so we can fill some of these in. These are all new to us as far as we haven't done any volume equations so far. So the first one we have is volume of a cube. And remember, what's special about a cube is all the sides are the same, okay? So you have your, each side is the same length. So because of that, and you would do like length times width times height, it's just going to be side cubed. So the volume of a cube is side cubed. You can write that on your formula sheet. If you don't, we can cover it when we get to volume of other shapes, okay? Volume congruence postulate said if two polyhedra are congruent, they're the exact same shape, they're the exact same size, then the volumes will also be congruent. All right, the volume addition postulate says the volume of a solid is the sum of the volumes of the non-overlapping parts. And that's similar to when we added areas together, we're going to add volumes together. All right, so let's look at volume of a prism in general. This is our generic formula for all prisms, okay? So the volume of a prism is the area of the base, big B, times the height, okay? Remember, anything with a capital letter means we've got to do work to find it. So whatever the shape of the base is, we're going to find that, and then we're going to multiply it by the height, okay? So that's the generic form for any prism. So that's one of them we want to put into our formula sheet. The volume of a prism equals big B times H. And that big B is the area of the base times H. We've talked about that earlier, that anything with a capital letter means we've got work to do to find that. Okay, one of the ones I want to kind of do a sidestep of, if you think of a box, and that's a real easy prism, okay? We often, and you've seen this formula before, so I want to include it so you know. So to find the bottom of this box or the base, you might do length times width, and then you do it times height. So volume of a box, like we're used to, and I really should call it a rectangular prism, but a box makes it sink in your head a little bit better, is just length times width times height. And that fits this one because that length times width is the base, the area of the base, and then the height of the prism. All right, if you're a cylinder, all cylinders have the same big B, and that big B is your circle. So your big B really is pi r squared, then times your H. So volume of any cylinder is going to be pi r squared H, okay? So those are our formulas we're going to go through. We're going to practice these. We're going to talk about how we can use those, okay? So that's really the main key thing of our notes today. All right, so page 2 here. We're going to start with this first prism. It's definitely a prism. It has two bases that are parallel to each other with those rectangles that join up with them. That's the definition of a prism. And we need to decide first, what is the B? I'm going to ask you often when we're doing these, what shape is the big B? Well, in this case, my big B this time is this triangle. Okay, that is my big B. So I'm going to stop before I find my volume, and I'm going to ask you, what shape is your big B? Well, it's a triangle. How do I find area of a triangle? Well, I do 1/2 base times height. Notice that B is a lowercase because it's just one number. So I look at that triangle. What is the base? Well, it's a 3. I look at the height. What's the H? The height of the triangle's height. Okay, that's part of that, and that's a 1. So I do 1/2 times 3 times 1, and I get 1.5. That is my big B. That is one value I'm going to need. Okay, so when I look at volume equals big B times H, my big B right now is 1.5. My height is from base to base, right? That's between bases. This is my prism's height. That's a different H from my base's height, okay? So this H, when we use it, is the height of the prism from base to base, and in this case, it's a 2. So I do big B, which is 1.5 times 2, and I get 3. My units was feet, and it's feet cubed. when I do volume. Okay, so super important to realize there might be more than one H in a formula, and we have to stop and say, what am I finding? If you're finding the big B, it's the H of the height of maybe the parallelogram or the triangle or the trapezoid or something like that. But if it's for the volume equation, it's height of the prism, which means from base to base, how high is it? All right, my second one is a cylinder, and a cylinder is nice because all the bases on cylinders are circles, so we just go pi r squared. So I don't even like to use this one, I just go pi r squared h. Okay, so I look there, my radius is 5, so I'm going to have 5 times, I don't even know where they're going with this, pi times 5 squared times my height, which is this 6. From base to base, again, from circle to circle is that height. All right, 5 squared is 25. 25 times 6 is 150 pi. Meters cubed would be my exact answer for that one. If I go to a decimal, it's about 471.2 meters cubed. Okay, just be ready, especially on cylinders, if I ask for an exact answer, to leave it in pi, okay? Or if I ask in terms of pi. All right, working backwards, this one tells us the volume of the right cylinder, and it gives us a number in cubic centimeters. We're trying to find the value of x, which happens to be the radius. Okay, so anytime we're dealing with any of these volume equations, the best thing to start with is the formula. Volume equals big B times h. I'm going to switch it, though, because it's a cylinder. I'm going to say volume equals pi r squared h. Okay, I'm going to be honest, even though it goes with that big BH, I would rather all cylinders get the pi r squared h so that you don't get confused on them. All right, do I know my volume? I do. It's 1253. They gave me that, okay? They gave me the value. Equals pi times my radius. Well, my radius is x, so I have x squared times a height of 10. All right, my job is to work to solve for x. Well, right now I have a 10 times x, or 10 times pi, times x squared equals 1253. I want to get x by itself. So first, I have this 10 pi connected to x squared. How is it connected? By multiplication. So how do I get rid of multiplication? I divide. So I divide both sides by 10 pi. Now, be very careful, because if you just type in 1,253 divided by 10 pi on your calculator, there's a good chance you're going to type it in and get the wrong answer, okay? Because you have to tell your calculator you're dividing by all of 10 pi at once. So you have two options. You either need to put a parenthesis around those 10 pi, or turn that 10 pi into a decimal, which would be like 331.4 maybe. So either take 1253 divided by 31.4 or 1253 divided by parentheses 10 pi, because you need to tell your calculator that whole chunk is doing the dividing, okay? So what is 1253 divided by my 10 pi? It's about 39.9-ish, and I rounded, okay? So you'll notice I already went to my about sign because it's not quite exact anymore. And that equals my x squared. How do I find my x? I take the square root. So take the square root of my 39.9, and I get about 6.3 for my radius, okay? So the radius is about 6.3. Radius is just linear, so we're going to measure it in centimeters, right? Not centimeters squared, not centimeters cubed. It's just a line, so it's just centimeters. All right, moving on to page 3, where we have Cavalieri's principle. Now, if two solids have the same height and the same cross-sectional area at every level, then they have the same value. It seems simple, but why is this really asking us this question, okay? I struggle to come up, especially on a two-dimensional, and draw a picture of this. Three-dimensional, sometimes I can. I think the easiest way to tell you this is to talk about like a straw. So if you had a straw that stuck straight up in your cup, okay, and the drink was filled to here, okay, or you had a straw that was slanted, or even think about a pipe maybe along the side of your house that's slanted, okay? So we would call this one a right cylinder, if that makes sense, because it's perpendicular straight up and down. But when something is slanted like this, it's called oblique, okay? It does not go straight up and down. But if I stuck that in my drink would still hold the same volume, the same amount of milk or the same amount of water, the same amount of Pepsi or whatever. It would still hold the same amount of volume, even though it's not a right one. So it's saying if they have the same height, so you'll notice here that my drink is the same height for both of these, and the same cross-sectional area, meaning like if I took a slice of them, I'm going to get a circle on both of them. Even though this one slants, and this one's straight up and down, they still have circles. Then they have the same volume. Okay, so basically it's just saying if something's slanted, something's not straight up and down, you can still find the volume as long as you know the perpendicular height, basically. Okay? All right. Find the volume of this oblique cylinder. So you'll notice right here I have like maybe a section of pipe that's slanted a little bit, and that's what I'm finding the volume of, okay, this oblique cylinder. So I don't change the formula because my same formula will measure the same amount. So volume equals pi r squared h. So I have pi, my radius is 5, and all I have to make sure is that my height is perpendicular. Because this is perpendicular, I can use that 8, okay? And I have 5 squared, which is 25. 25 times 8, that's like 8 quarters. That's 200 pi. There's my exact answer in inches cubed. But if I have to buy, let's say, some, copper to fill that or something like that, I need to know exactly the inches squared. Run that through your calculator, and it's approximately 628.3 inches cubed. Okay? So, by the way, we don't want to find surface area of that slanted oblique figure, but volume we can use the same formula for, okay, but not surface area. All right, so quick margin note here. Solids that are glued together, you need to add the volumes. Solids that are cut out, you need to subtract the volumes, okay? And it's very, very similar to what we did in the area equation. We just need to use volume equations today. So the volume of this cylinder, solid. Well, what's happening here? Well, it looks like I had a cylinder, okay? And then it looks like what I did is I cut out a cylinder, okay? So that's what it looks like happened. So that's what I'm going to work with as far as my equations go. So volume of a cylinder is pi r squared h, and I'm going to subtract pi r squared h. Okay, pi never changes. The radius, I'm starting with my big cylinder. Well, from the center out, I'm at 3 millimeters, so that's my radius. My height here is 7. On that small cylinder where it got cut out, like they drilled that hole all the way through, it looks like it has a radius of 1, and its height is the same as everything else, so it's also 7. Okay, hint, leave everything in terms of pi as long as possible. It'll make things so much easier, okay? So 3 squared is 9, 9 times 7 is 63 pi. Over here, 1 squared is 1 times 7 is 7 pi. Because they're both in pi, it makes it easy. 63 pi minus 7 pi. That gives me exactly 56 pi millimeters cubed. Okay, that's my exact answer. And as a decimal is about 175.9 millimeters cubed. Okay? Leave it in terms of pi as long as possible. All right, let's try some more examples. Right here I have a rectangular prism. It's a box, okay? Volume of box, I like length times width times height, okay? You can do it, big B times H, we'll do it, it's gonna work. If I call this one my length, this one my width, and this one my height, okay? I'm gonna do 11 times 4 times 5, and I'm going to get 220 meters cubed, okay? Just a quick side note, because I just want to make sure you can see this, volume of big B times H. If I say that, I might say, well, what's my big B? Well, my big B is a rectangle, okay? If I look at this rectangle down here, it's going to be base times height, right? So I'm going to do 11 times 4. So I'm going to get a big B of 44. My height goes from this base to its other base, so this is my height here, okay? So I multiply by 5. Well, guess what I get? The exact same thing as before when I did length times width times height. So if it's a rectangular prism or a box, you can do length times width times height and get the same thing that big B times H will get you. All right, number 2, this right cylinder. Anytime I see cylinder and I know I'm doing volume, I want volume equals pi r squared h. The radius here is 6. The height here is 9. 6 squared is 36. 36 times 9 is 324 pi, and that's in feet cubed. That is my exact volume. As a decimal, if we round it to about 1 decimal place, about 1,017.9 feet cubed, okay? If you haven't caught on yet, volume is so much easier than surface area because you just multiply your values together and you're done, okay? So the key is make sure that height is always perpendicular. For number 3, I know the volume of this right cylinder. They give it to me, And they gave it to me in pi. I love when they give me volume in pi for cylinders or circles. It makes things so much easier. We're going to work to find the value of x, which happens to be the diameter. Okay, I'm going to tell you right away, we're not finding the value of x. I'm going to work to find the value of y, which is a radius, and I'll use that to find the value of x, which is the diameter. Okay, so volume of any cylinder is pi r squared h. Always start with the full equation, which means there's an equal sign and there's another letter on the other side. In for volume, I'm going to plug in 200 pi. In for the radius, I'm going to plug in that y I just put in there, and my height here is 8. Well, on this side, I can join my 8 and pi. I get 8 pi y squared equals 200 pi divided by 8 pi. This cancels. That cancels. 200 divided by 8 is 25 equals y squared, which is a beautiful number because now when I take the square root, y equals 5. So my radius is 5, okay? But I wasn't looking for my radius. I was looking for that x, which is the diameter. So I'm going to do 2 times my 5, so x is going to be 10 centimeters here. Okay, don't try to plug that d into your equation because that's not going to be pretty. I would just solve for the radius and then double it. All right, moving on here. Oblique cylinder, find the volume. Remember, it doesn't matter if it's oblique or if it's just straight up and down. We use the same formula, pi r squared h. My radius here, careful, is 6, okay? And my height has to be perpendicular. Oh, I need this height. They didn't give it to me. Well, I do know this side over here is 18. That means this side is 18, and I happen to have a 30, 60, 90 triangle. Do I know my short, my doubled, or my radical? 3. Well, across from the 90 is always the doubled of 18, so my short is 9. And if I take my 9 and take it to the long leg, that's going to be 9 square root of 3, which will be my height. All right, that's my height, 9 square root of 3 using my 30, 60, 90. All right, 6 squared is 36. 36 times 9 radical 3. I can multiply the 36 times the 9. That gives me 324 radical 3 pi. That is a very, very exact answer with radicals and with pi, millimeters cubed. If you want to, you can turn that into a decimal on your calculator. It's about 1,763 millimeters cubed. Make sure you close that parenthesis off the radical 3 before you put the pi there, or bad things could happen. Okay. All right. On number 5, this composite solid. Well, what do I have here? What's joined together? Looks like on the bottom I have a box, and then I have half a cylinder, okay? Volumes, again, real easy to work with. We don't have to worry about things you can't touch like we did with this surface area. So for the box, I'm going to do length times width times height. For the cylinder, I'm going to do half of pi r squared h. So my length, width, and height are 4, 4, and 4. My radius, be careful, that's only half of it, is 2. And my height, that's from cylinder, circle to circle, that's a 4. Okay, so make sure we get the right number in for that. 4 times 4 times 4 is 64. 2 squared is 4. 4 times 4 is 16. Half of that is 8 pi. Right there is my beautiful exact answer. All right, and as a decimal, if I plug that in my calculator, it's about 89.1 inches cubed. Okay. I have one more I just want to kind of touch on a little bit. If you peek at this next page, it's not in your notes, but you can just kind of follow along here so you can see. If you have something like this as a composite, your choice as far as where you break it up and how you handle this, I'm going to break it up maybe right here, okay? If that's the case, this bottom box right there, okay, just has those dimensions of 7, 1, and 2. So that volume is going to be length times width times height, 7 times 1 times 2, which is 14. All right? Now for this top one, okay, just this top part, we have to make sure we don't use what's already used. Well, I know that I have a height of 3. I know I have this width at 2. Now I have to think of this width right here. That's the width I'm missing. okay? It's how deep this is. It's this one, which is this one, which is this one. It's the same one. Sorry about that. It's the same one from over here. So it's just one. So this one also is length times width times height. So I do 2 times 3 times 1, and I get 6. I add those together, and I have a total volume of 20. Okay? No units given, no units needed, but that's where I'm going to go on that one. Okay. I know on the last page it said all this bookwork. We're not on a bookwork. We've got a worksheet. Okay, so look at your 12.4 worksheet. Please show me your formulas. Please show me your work. Please make sure you find your big B on its own before you plug it in. All right? All right, sounds good. Good luck. Let me know if you have any questions.